Hello, we're back again. We're looking at the correlation, linear regression this go around. We've got two variables here. We're looking at the correlation between exam scores and anxiety levels. So for this, we're going to look at a Pearson correlation test. We'll just jump right into it. With the Pearson correlation, you need both variables to be interval ratio or continuous. So let's look at our variable view first. So we've got anxiety rating and exam scores. So they're both going to be numeric. We've just made the width 8 decimals too. Not that that really matters, but just make it the same across the board. So we're going to go over here to measure, and these are both going to be scale, which means they're continuous. So that's really all we have to do there. We just want to make sure there's nothing here in the values or anything out of the ordinary there. So that's pretty simple there. So let's go back to the data view, and here are our data points. So we put those in. Here's our anxiety ratings and their corresponding exam scores. So what do we need to do first? With the Pearson correlation, we need to look at the assumptions, which we have 4. So the first assumption is that the two variables should be interval or ratio. They're continuous. So we've already established that. So assumption 1 is met. Assumption number 2 is that there is a linear relationship between the two variables. Now, how we find that is we are going to create a scatter plot. So we'll do that in a minute. I just want to go ahead and just touch on the other two assumptions before we go any further. So number 3 assumption is there are no significant outliers, and we can look at this in the scatter plot as well. And then assumption number 4 is approximate normal distribution. So in that, we can look at the Shapiro-Wilk test in our descriptive statistics. So let's jump right in. So for the scatter plot, we are going to go up to graphs and then down to scatter plot. And we're just gonna do a simple scatter and then go down to define. And so even though they're both continuous, we do have a dependent and independent variable. So our dependent variable, which is exam scores, because the exam scores are dependent on the anxiety rating. So our dependent variable exam scores is going to go on our y-axis, and our independent variable anxiety rating is going to go into our x-axis. We don't really need to do anything else here. We just want to look at the plots. Make sure I'm not missing anything. Yes, okay, so we just go down here and click OK. And here is our graph. So we can, if we just kind of look at just this like imaginary line, hang on, let me try this. If we double click, I'm going to bring this down here into our screen. Here is our scatter plot. We can add this line of fit here, and let's look at that. We're going to add it, and here we go. Close that, and here is our line of fit, and we can see that we don't really have any outliers, because we don't have any like way out here, way here. So they pretty well fit. We have no outliers, and then the linear relationship, we can look, and it's pretty linear. They all kind of follow the same path here. So we've established that we've met the assumption number 2 for a linear relationship between the two variables, and then assumption number 3 that there are no significant outliers. So we can just X out of that, and we're back here to our data. let's look at the assumption number 4, and for that we're going to look at the Shapiro-Wilks in our descriptive statistics. So we go up to Analyze, Descriptive Statistics, down to Explore, and we're going to look at each one of these individually. If we put them both in there, it looks weird. It doesn't really, it deletes a lot of the data points, so we're going to look at each one independently. So let's look at exam scores first. Don't think we don't need to, change any of the statistics or anything, or we don't need a plot. So let's just look at exam scores first. And let's go down here to the Shapiro-Wilk, and we look at the significant value of 0.615, and that's well over our significance level of 0.05. So that indicates that there's an approximate normal distribution, at least for exam scores right now. So let's go back and look at the anxiety level. Go up to Analyze, down to Descriptive Statistics, Explore. So we're going to take exam scores out and move anxiety rating over, and look at that one. And we scroll down here to the Shapiro-Wilk, and our significant value is 0.113. And again, it's well over our significance level of 0.05. So we have an approximate normal distribution for that variable as well. With that, so now we know that all 4 of our assumptions were met. We can get into the analysis of our data. So for the correlation, the Pearson correlation, we're going to go up to Analyze, down to Correlate, and we're going to pick this bivariate here. So click on that, and all our variables are already over there, but if they weren't, we just move them both over here. Make sure the Pearson box is checked, as well as the two-tailed significance. Let's go over to options. We can click this means and standard deviations. It just gives us a little bit more information in our output, and then exclude the cases pairwise. That's fine. We don't need anything in style, bootstrap, or confidence interval. So we are good to go. We're going to click OK. And here's all of our stuff for the Pearson correlation. So with the output, we're going to look down here at the correlations. The descriptive statistics, we don't really need to look at that much for this one. So down here in the correlations, we need to look here at this top row, the Pearson correlation. And you'll see this value here. And before we delve into what this means, the Pearson correlation value can be 1 to -1, and it can fall anywhere between those lines. And the closer it is to 0, you're looking at there's no correlation. If it's 0, there's no correlation. So the closer it gets to 1 or -1, you're looking at either a negative correlation or a positive correlation. So those can be your values. So looking at this value here, this top correlation, this Pearson correlation, we've got a -0.893. So the 0.893, you're getting real close to -1 here. So that shows us that there is a strong correlation between the two variables. The fact that it is negative tells us that there is a negative correlation. So as one variable goes up, the other one's going to go down. That's the negative. That's a negative correlation. Let's see, is that all we need to look at there? And then the fact that it's close to -1, that's a pretty strong correlation. All right, and that's really all we needed to look at for the correlation. So now we're going to delve into our linear regression analysis. So what this looks at is the outcome variable based on the input variable, or you can call that the predicted variable, which is our dependent variable. So we're predicting exam scores based on our independent variable, which is anxiety levels. So let's look at that. And per the assignment, you don't need to look at any assumptions, but we met all of the ones for the correlation analysis, so we should be good to go. So to run the linear regression, we're going to go up to Analyze, down to Regression, and then over to Linear. And then here we have our dependent variable versus this is our block. This is where we're going to put our independent variable. So exam scores goes here, and our anxiety rating goes here. We don't need to do anything with statistics or plots for this analysis. We just want to look at our linear regression. So we're just going to go down and click OK. And here we have quite a bit of stuff. So first we're going to look at this model summary table here. And we're looking at the R value and the R squared value. So our R value is the linear regression. So it looks at our correlation. And we kind of already knew this from our Pearson correlation, that was a negative 8.93. So this just kind of reaffirms it. It's, 893. It's a real strong correlation. But then we've got this R squared valued here. The 0.797. And this is how much the dependent variable can be explained by the independent variable. So how much exam scores can be explained by anxiety levels. And what that's going to be, it's 79.7% is what that indicates. So it's pretty large. And from that, we're going to go down and look at the ANOVA table and look at this regression row here. And the significant value for that is less than the 0.05, which means that the regression model statistically significantly predicts our outcome or our exam scores. So our model statistically significantly predicts exam scores. All right, so what do we have left? We've got this coefficients table down here, and this will come in handy. It'll help us create the regression equation. So this shows us information to predict exam scores from anxiety, and if anxiety levels contribute statistically significantly to the model. So we're going to look at the significant value here, the bottom one, the anxiety rating, that row there. And it is less, the significant value is less than the 0.05, so that means it is statistically significant to the model. And then, but we're going to go back over here to this value here, this negative 4.671. And that's going to help us create the regression equation if you need it for this particular assignment. And this will be our slope. So the regression equation is going to be your exam score equals you can round this up to 107 minus 4.671. So what that regression equation is, y equals a plus bx, where your y is your dependent variable, or our exam scores in this example. our B is our slope, which is this negative 4.67, and our X is our anxiety level. So we can create the regression equation based on the information we have here in the coefficients box. Okay, so that was the Pearson correlation and linear regression analysis for exam scores and anxiety levels. And there you have it.